Okay, everybody. If you missed, let's see, Wednesday or Thursday, then you missed, obviously, the day we took the double quiz on ionic and covalent bonding. So this was the review that you were supposed to have done. And I'd say only maybe just over half of you actually did it. So, oh man, I still have quite a bit of coffee to drink. So if you happen to miss it, then watching this would probably be a good idea. So the first question was to sketch the dot diagrams and then the ion symbols. Now, some of you forgot what ion symbols even were. And so remember, well, first of all, let me back up. The dot diagrams, you're supposed to look at the valence number and then know that that's how many dots go around the symbols, which, again, we've been doing dot diagrams for a long time, like over a month for sure. So you should be very familiar with dot diagrams. Now, I just made tiny little dots. Normally I draw a nice big fat dot, but I was trying to hurry. So those are the dot diagrams. Hopefully you have those that way. Now, the ion symbols are the element symbol with the oxidation number as a superscript up above, right? Superscript of the oxidation number. Now, I'm hoping you remember what the oxidation number was for. That is supposed to be the charge of the atom if it takes care of the octet by either gaining or losing electrons, okay? Gaining or losing electrons will make these atoms that charge based on what they have in their valence level. So for instance, phosphorus having 5 in the outer level, it needs 3 more to complete the octet. If it gains those 3, that makes it a -3 because it's gaining 3 electrons, 3 negatives. On the flip side, if you look at rubidium here, with a single electron in the outer level, it's not going to gain 7. It's going to kick out the one that it has, or lose the one that it has, or someone else is going to steal the one that it has. That way, the next level down is full with 8. And then rubidium will have an octet, but it will become +1 because it lost a negative. It lost an electron, which is negative, which makes it positive, the opposite. So hopefully you remember why those are. You at least need to know where they are and what to do with them when you find them, okay? So those are the oxidation or the ion symbols with the oxidation number as a superscript. These are the dot diagrams. We need the dot diagrams for both ionic and covalent. We only need the oxidation numbers for ionic. They don't get charged. If they're bonding covalently, they don't get charged. So the first set of questions here, what type of bonding, if numbers 1 and 2 were going to form a bond, so if 1 and 2, if phosphorus and bromine were going to form a bond, what kind of compound would it even be? Hopefully you said covalent. Covalent is what that would be. How do we know? 2 reasons. Number 1, phosphorus is a nonmetal, bromine is a nonmetal. They are both nonmetals. That indicates it's going to be covalent. Second reason is because they're both nonmetals, look at the charge they would have. If they satisfied the octet by gaining and losing electrons, they would both become what? -3, -1. If they're both negative, what won't they do? They won't attract. They're not opposites. They're the same kind of charge. And what do like charges do? They repel. They will not attract. So, for this case, the only way those two can combine is if it's covalent. They will not be charged. They will get together and try to share their valence electrons. Now, the next question was, what would be the compound formula? Oh, that's tough because, how are they going to fit together? Well, if you remember something I said the other day, the halogens, which bromine is one of them, the halogens and hydrogen are very easy to use in these covalent examples because they have a single empty spot. and they can plug in anywhere there's an empty spot. So bromine, being a halogen, just like chlorine and fluorine and iodine that we've used as examples as well, those having 7 in the valence level in a single opening allow them to snap right in to empty spots. Well, how many empty spots does phosphorus have? 3, right? So the bromine can slide in here to fill an empty spot. Another one can slide down in here to fill an empty spot. And another one could slide over here to fill an empty spot. So it looks like you would take 3 bromines to complete and fill all of those empty spots. So that would be, the formula would be what then? PBr3 would be the formula. 3 bromines for the 1 phosphorus. Now the dot diagram, and of course there's the name too, phosphorus tribromide, okay? Tribromide because there's 3 bromines. We do not put mono in front of phosphorus because there's only one of them. We just have to say phosphorus. Phosphorus tribromide. Has to be tri because there's 3. Bromide because all of the compound names, the second element has an "ide" suffix. All right? So phosphorus tribromide would be the name. The dot diagram would look like this. Again, like I had said, plugging in an empty spot here, plugging in an empty spot here, plugging in an empty spot here. All 4 atoms are filling each other's empty spots and sharing. Okay, that's covalent. Next one is you're supposed to combine numbers 1 and 4. Well, 1 and 4 would be phosphorus and aluminum. What kind of bond is that going to be? Ionic, because aluminum is a what? Metal. See, +3. We have a +3 and a -3. Now, I listed them like this, +3 and then -3. Why did I put aluminum first? Phosphorus is listed first here. Why did I write aluminum first? Hopefully you remember that for ionic bonding, which one gets listed first? The positive one. Positive one first, negative one second. That's something else you're going to have to remember. The positive one is always listed first. Now for covalent, the rules are complicated. I will just give you those in the order that they should stay in. Okay? Whatever order I give them to you in, that's the order they need to stay in for covalent. All right. Nobody even probably questioned that it would be the P first and then the Br because they're listed from left to right. But for the ionic, you might be thinking that the P would go first and then the aluminum second, but it can't be. The positive one is always listed first, then the negative one, which is why then I would list them like this, which would be the formula ALP, one of each. Why? Because it's a +3 and a -3. How many +3s and how many -3s does it take to make neutral? One of each. And the name is just aluminum phosphide. It's not monoaluminum monophosphide. It's not aluminum monophosphide. We don't use prefixes on the names of ionic compounds because we have oxidation numbers that tell us how they have to combine. Aluminum and phosphorus have no other way to combine than one of each. That's the only way they can make neutral with a +3 and a -3. No need for prefixes because the oxidation numbers tell us that. And then, of course, how do you show that in terms of dot diagrams? Well, you show a transfer of electrons from the aluminum. The aluminum electrons are going to get stolen by the phosphorus. The phosphorus wants to fill its octet. Aluminum has 3 electrons in its outer level that it's never going to gain 5 to make an octet. Aluminum won't. It's going to allow its electrons to be stolen by phosphorus. Phosphorus then will have a complete octet. Aluminum appears to have nothing. But we have to remember, like I wrote down over here, if you look at aluminum's electron numbers on the side of the box on the table that I gave you, you would see a 2, an 8, and a 3. The 3 is the outermost level. Those just left. What's left? 8. The next outermost level, the next one down, is full with 8. That's an octet. So aluminum has an octet even though we don't see it. Covalent, we will always see the octets in the picture. Okay. ionic, we won't see the octet on the positive ion because that octet is hidden. It's the next level down that becomes the outermost level once the 1, 2, or 3 on the outside take off. Then we made a list here. We talked about ionic versus covalent versus both. And so we said that ionic is dealing with metal. There's a metal involved. There are a few exceptions that I won't talk about. Covalent, we're dealing with nonmetals, sometimes metalloids as well. Both bonds are referring to the octet. They're both atoms trying to satisfy the octet through different means, transferring and sharing. Oh, that's next. Transfer is how ionic bonds make an octet. Sharing is how covalent bonds make an octet. They're both involving valence electrons, and we need dot diagrams to show how it works. But again, the dot diagrams show a transfer for ionic. They show the sharing for covalent, right? There's no prefixes on ionic names. There have to be prefixes on covalent names. We're dealing with oxidation numbers. We need the charge values to make the ionic work. And then I kind of look at the covalent like little puzzle pieces. Okay, those are like little puzzle pieces that fit there together so that we can make pairs around the atoms. And then, this was brought up as well. It's always the positive first, then the negative. Now for covalent, I will give them to you in the order that they belong. Lastly, I had these two things written down, which weren't on the review anyway, and I should have probably deleted that, but S2N5, just cover that up for a second. What is the name of S2N5? Well, that would be disulfur, 2 sulfurs, pentanitride, because there's 5 of them, so pentanitride, disulfur pentanitride. That's how you would name it. Now, what's the formula for tetracarbon decahydride? Tetracarbon, tetra is 4, decahydride, that's 10. Deca is 10. And so that would have to be C4H10. Okay. So that's the discussion we had before the double quiz. Again, there's an ionic section, there's a covalent section, front page, back page. And then on the covalent side, there's a couple questions where you have to be able to differentiate. If I give you a name or a formula of a compound, you should be able to have a pretty good idea whether it's covalent or ionic by looking at the name or the formula. Again, we're looking for a metal if it's ionic typically, and we're looking at prefixes if it's covalent in the name. So anyway, that's what we talked about. If you weren't here, then obviously you missed that. Hopefully this will help you prepare and know what you're doing for the double quiz. So good luck on it if you haven't taken it yet. And I'll see you, next week, I guess most of you. Bye.